This is the Gdt Terminology tutorial part 1. To start off, open up the Gdt Terminology PDF file. So what we're going to be doing in the tutorials from now on is we're going to be going over Gdt. So we're going to be going over the terminology. We'll go over why we use Gdt. We'll have a Gdt reference guide for when you're making your drawings. And after that, we'll be going over each specific Gdt symbol and applying it into our drawings. So what we're going to be doing is the Gdt terminology. We're going to split it into two parts. In the PDF, there is 21 Gdt symbols and terminology that we want to go over. So in part 1, we're going to go over the first 10. So we'll start off with number 1, the all-around symbol. And it is a circle enclosing the corner of the leader, indicates that the tolerance applies to all surfaces around the part. And you can see by the drawing here that you have a arrow and a leader pointing, and then you have a circle that's at the corner, or where it kind of bends. Now usually what you'll have is a Gdt frame that will be later on, that will explain what it is, with all your Gdt information in it, and it will be pointing to your part. So when you put the circle on it, rather than having 3 or 4 Gdt frames pointing at 3 or 4 different spots, by putting a circle, it means that all surfaces around the part apply to this Gdt standard that you're applying. So putting the circle reduces the amount of Gdt frames that you have to show and point with. The second one is Angularity, and it's the flatness of a specified angle to a datum or center line. So we can see that this is the symbol here. It looks just like kind of like an angle, and that will be in your Gdt box. So you'll have that representing, telling the person looking at it that it's an angularity Gdt, and then after that you'll show your the angle or the tolerance of the angle that you want it to be within, and your datums after that. Number 3 is between, and it indicates a profile tolerance applies to a specified zone between points defined on the part. And what it is it's just arrows that go back and forth. And how you'll use this is when you're doing a drawing, some are going to be something like line profiles or surface profiles, and you'll have specific points rather than making the whole part apply with the tolerance. You might just want it on a certain area or certain points. Doing it on certain points rather than like the whole outside profile would reduce the cost of the part, because you want like a certain part of it within a tight tolerance and the other bits don't really care. So what you would do is you would have, say, on the left side it'd be point A between point B, this Gdt must apply. Number 4 is Circularity, and it compares the circular feature in question to a perfect circle. So with Circularity, if you have a obviously a circular feature on your part, you're going to apply a tolerance, and that's how close that circular feature needs to be to a perfect circle. Number 5 is Cylindricity, and it's a condition when the axis of elements are common to a specified datum. So what this is if you have say a couple cylinders or like a hole and a bolt, you want them concentric to a certain tolerance. So this could be during assembly, or it could also be during production if it's, say, a couple cylinders on top of each other. So you'll show this, and then you'll show the tolerance that you want to apply to it. Number 6 is Cylindricity, and it compares the cylindrical feature to a perfect cylinder. So this is similar to Circularity. Circularity would just be a line, and Cylindricity would be a line like a circular line, but it goes all the way up, so you have kind of like a volume to it. So you're comparing a cylindrical feature to a perfect cylinder with your applied tolerance. Number 7 is a datum feature, and we use this to establish a datum on the part. So a datum feature, what it is it's a square box with a little triangle, and usually you'll use this to kind of define like a specified surface or a hole. That's going to be a datum feature in your drawing. When we go later on into the tutorials, datums are very important because they kind of start and define how you're going to measure everything else on the part. So datums are very important, and this is the symbol that we use to define datums on our drawings. Number 8 is a datum target, and it's a specified point, line, or area used to establish datum references. And what it is it's a balloon that has your datum, so in this case it's A1, and you point to an area or a point. When you're manufacturing parts, because parts are very complex and whatnot, there may be different types of places when you make like a fixture to put it into that it has to rest on, and a datum target would be kind of like another area that it's going to be resting on. So you'd kind of define a certain surface that would rest on it. It's not a datum feature, but it's just kind of like an area that it's going to be resting on in your fixture. And our Gdt control frame is a rectangular box which includes Gdt symbol, tolerance, and datums to define the callout. So you can see that this is the figure right here. We have our Gdt symbol, we have our tolerance, and then we have our datums that we're going to use when we're measuring the Gdt feature. Number 10 is flatness, and it's a measurement of the highest and lowest points on the defined surface. So with this, it's just like the flatness of the top of a surface. We're looking at like the highest peaks and the lowest peaks, and then you're going to put a tolerance after to define where it's going to fit in between. And that is the first 10 of our Gdt terminology, and that concludes our Gdt terminology part 1.